All right, did everybody get both a copy of the notes and a copy of the homework? If you did not, please let me know. Other than that, we'll dive right in here. No time to waste. So what we're going to be looking at this unit is graphing polynomials. So we're going to get into some graphs that are more complicated than what you've seen up to this point. However, I have good news for you. We're not going to be really detailed with our graphs. We're going to look at important features of the graph, put those down, and then make a sketch of what the rest of the graph would look like. We're not going to get 100 points on each one, which is what you would really require if you wanted to make a detailed graph of it. That's what computers are for. They're much better at that than we are. We are just going to look for the important pieces of the graph and use that to make a sketch. So we're looking again at polynomials, meaning it's got x cubed, x to the fourth, x to the fifth, and then others added on. So you'll see things like this first example, 3x to the fifth minus 4x cubed plus 2. We're going to learn how to graph that now. And before we do that, we need to talk about just some vocab again to start off the unit. The first term that we're going to talk about is degree. The degree of a polynomial, come on in. Do you have a mask? Okay. Let me know if you need one. The degree of a polynomial is its highest exponent. So when it's written out like this, for this first one, 3x to the fifth minus 4x cubed, come on, there it goes, plus 2, I look at all the terms and I find the highest exponent on a variable. So in this case, it's x to the fifth power. That 5 is my degree, okay? Nice and easy. You're finding the highest degree, highest exponent, that is the degree of the polynomial. When it's multiplied out like this, when it's just one term plus another plus another. The next one, g of x right here is not in the order it should be. Normally the highest exponent is the first one, but every once in a while they're mixed up. So this one, we've got an x squared, an x cubed, and an x to the first power. So this one's degree is the 3, the highest one. This last one, 2x plus 1, it has an x, right? Even though there's not a degree listed, an exponent listed, we know that there is one x here, x to the first power. Sometimes they won't write out that 1. They usually won't write out that 1, but it's still there. If it was x to the 0 power, there wouldn't be an x, right? X to the 0 power is just 1. So here our exponent is 1 on that guy, so this is a degree of 1. Does everybody think if you were looking at a polynomial like this, you could say what the degree is? Yes, no. And hopefully, again, that one's pretty straightforward. The leading coefficient, once you find that degree, find that highest exponent. Put the phone away. Focus. Once you find that highest exponent, the number out in front of the x, that is your leading coefficient. So those same ones that we were just looking at, the 3x to the fifth, there's the 5. I don't care about anything else after that for right now. That's the most important term. So that 3x to the fifth power, its leading coefficient is the 3 out in front. Okay. The reason we're looking at these terms in particular is because as we get bigger and bigger numbers into x, they take over. 3x to the fifth is going to so overwhelm every other term in that polynomial, we can ignore them. And so we're looking at these important pieces here, the leading coefficient and the highest degree. That's going to tell us about what's called the end behavior in just a moment. Those are the most important pieces. So the next one, again, that highest degree was the 3 right there. That's the one we're looking at. Its leading coefficient is -5. So do watch out for the negatives, right? That is a piece of it as well. And then h of x equals 2x plus 1. Again, we're just looking at the 2x right there. We said that it was a first power, a leading coefficient of 2. Can you all find that important term when you're looking at a list of a polynomial, essentially, looking at all the different pieces of it? Can you all find the highest exponent and its leading coefficient? not, let me know, because that's how we're going to determine what's called the end behavior of the function. There are 4 possibilities for end behavior. One is high, high. The idea that I have a polynomial that looks kind of like this. The 2 ends are going up. That's high, high end behavior. That happens for anything with an even degree. Gonna have to make my pen tool a little smaller here. Even degree and a positive leading coefficient. From now on, I'm going to abbreviate leading coefficient as just LC, okay? So that leading coefficient, that was the number out in front. So find that exponent. If it's even and the leading coefficient is positive, it's going to have high, high end behavior, like a positive quadratic, right? X squared has high, high end behavior. Low, low end behavior. Let's make this a little bit smaller. Oops, nope. Low, low end behavior is going to look like this. That is also going to be from an even degree. Come on in, welcome. Also from an even degree. But now it's a negative leading coefficient. A negative leading coefficient. So a negative x squared graph. A negative x squared graph has low, low end behavior. The trick is, those are things that we already know, but we're going to be able to use the same stuff for more complicated ones. So, for example, if I have negative x to the 4th, it's going to be the same end behavior as negative x squared. Okay, they're both going to be low, low. Low, high looks like this. Think like a straight line. One end is going down, one end is going up. This is going to be for odd degrees. Odd degree and a positive leading coefficient. So y equals 2x. Starts low, goes high, it's a straight line, has one end going down to the left, one end going up to the right. Whereas high-low look like this. Starts off high, goes down low. That one's going to be an odd degree also. But it's going to have a negative leading coefficient. Does everybody understand that those are the only possibilities? There's only 4 options. And that covers all of them. Every single graph that we're going to do is going to match one of those 4. So our goal for today is for you to be able to look at a function and know which one's it going to be. And again, this is all you're looking for. Whether the exponent, the highest degree, is even or odd, and whether the leading coefficient is positive or negative. If you have that, you've got everything you need. Okay, so let's try it. State the leading degree, or sorry, state the degree, leading coefficient, and end behavior of the following polynomial. All right, so everybody looking at this, what's the highest exponent that you see in number 1 there? Just shout it out. The 4, right? That's our highest exponent. So that's our degree. 4th degree. Technically, you'd like 3rd, 4th, 5th, 4th degree. If you just put 4, that's okay. 4th degree. So again, everything else you can ignore. You don't care about anything else on here for now. We'll get to that stuff later. But that 3x to the 4th, 4th degree, what's its leading coefficient? 3. Now that we have both of those, is 4th degree, is that even or odd? The 4th degree is even. Does that make sense? So even. The 3, yes. So remember that evens are 2, 4, 6, 8, 10. Yeah, it's as simple as what you've done before, right? There's no new vocabulary for even or odd. It's literally look at the number that you picked. Is it an even number or an odd number? So 4th is even. The leading coefficient, is that 3 positive or negative? Positive. So this is an even positive function. So now look back at what we had said. For positive leading coefficients and even degrees, what's the end behavior? High, high. Does that make sense to everybody? That's all we're doing today. If you've got that, you're pretty much done with today's lesson. High, high. Okay. Now, let's look at number 2. Do another one. This one's not in the right order, so be careful. What's the highest exponent? 2, right? Right there. So we're going to say this is a second degree. Does that mean it's even or odd? Even. And again, connect it with graphs that you already know. Even degrees, quadratics, okay? It's going to behave like a parabola. It's either going to be high, high, or low, low. Leading coefficient. What's the leading? Okay, this one's a little tricky. What's the leading coefficient of this one? -1, right? Don't forget, if you put negative, you'll be fine, but really it's -1. And again, that means negative. That's the important piece here. So even degree, negative leading coefficient, the end behavior now. Look at our options. Which one's it going to be? Does everybody agree? Low, low? Again, if you're ever stuck, think about a quadratic. If it's positive x squared, it's high, high. If it's negative x squared, it's low, low, right? That's going to be the same for anything with an even degree. Okay, number 3. What's its degree? 1, right? As long as it has an x, it's not going to be 0. The only way you have a 0 degree is if it's a constant function, no variables at all, no x's. So this is a first degree. Okay, now there's some debate here. Let's keep it pretty simple. First degree, 1, is that even or odd? Odd. Now, you might go to some math teacher somewhere and they'd say, well, 1 really doesn't count. For us, treat it like it's odd. Okay, we don't need to overthink it. It's not even. That's the important thing here. So odd degree, leading coefficient. It's 1, right? There's not a number out in front, but we can assume it's a 1. So leading coefficient, 1. Is that positive or negative? Positive. Now, everybody, the trick with today's lesson is remembering which thing you're looking for. Remember that the exponent, we want even or odd. The leading coefficient, we want positive or negative. Don't switch those, okay? So odd, positive. What's our end behavior? Low, high, just like a straight line, a positive straight line. Low, high. Number 4. What's the degree? 5th degree. That did not work. 5th degree. There we go. What's its? Okay, so 5th degree, even or odd? Odd. Leading coefficient, -2, which is, you just said it. Is it positive or negative? Negative. And you see how right now I'm helping you guys out by asking you the question. You have to remember which question to ask. Does that make sense? You've got to decide, is it which one is even or odd? Which one's positive or negative? So 5th degree is odd, -2 is negative. And once we have that, we can decide on the end behavior. So everybody, what's the end behavior for this one? High, low. If my pen will work, there we go. High, low. All right, turn to the next page. Actually, no, let's practice this. turn to the homework. Everybody look at the homework. I want you all to try number, let's see. I mean, you can do numbers 1 through 6 right now, but let's start with numbers 1 and, no, start with 2 and 3. Everybody start with 2 and 3. If you get those done quickly, you can do all of 1 through 6. Everybody go to the second page of notes now. Now we're going to do backwards. Same exact thing, but going the other way. So they're going to give us a graph and ask us, okay, what's the degree? What's the degree? And what is the coefficient? Now, we're going to add one thing in here. Do I have it on my notes already? Looks like I don't. So I want you to add one thing in. Every time the graph changes direction, its degree is at least one more than that. Okay, so let's add that in just on the side here. I'm going to actually type it in so it'll be nice and clear. So the degree of a polynomial is at least 1 plus the number of direction changes. That's actually beyond what you need to know for today's lesson, but I figure we might as well say it. That sounds confusing. It's actually really easy. So the degree of a polynomial is at least 1 plus the number of direction changes. So with that in mind now, with that in mind, look at number 5. Let's go backwards. What's the end behavior for number 5? Right, look at the left side. It's going down. That's low. Look at the right side. It's going up. That's high. So if a function has low, high end behavior, what do we know about its degree? Is it even or odd? It's got to be odd. If they don't match, if they're not the same, it's odd. Now, what about that whole 1 plus the number of direction changes that I just said? Does everybody see this graph changes direction twice? It's going up and then down and then up again. So that's 2 direction changes. It starts off going up, changes to down, changes back to up. That's 2 direction changes plus 1. This is at least degree 3. Does that make sense? That is beyond what you need to know for today's lesson. That's advanced, okay? If that makes sense to you, great. That can be useful later on. But for now, you all just need to be able to identify that it's odd, okay? So it's probably at least degree 3, maybe degree 5. That's more than you need to know for today. As long as you can say it's odd, you're set. Now, the coefficient. We already decided that it's odd degree. If it's low, high, is the coefficient positive or negative? Positive. Again, think of either a straight line or here's another trick. Guys, if it ends high, it's always positive. If it ends high, it's positive. You can put that down over here. Let's say positive. Positive LC ends high. Negative LC ends low. Don't worry about the direction changes. That's extra, okay? As long as you look at, for what we're doing now, the end behavior is all you have to look at, okay? But again, that whole direction change will be helpful later on, but you don't need it now. You don't even really need it later, but again, it'll help you connect what's going on, if that makes sense. So if you have questions about it, let me know. But again, don't be worried if it's confusing right now. So we've got odd degree. We said it has to be a positive leading coefficient because it ends high. It ends high, so positive. When it says justify, your justification is literally just the end behavior. Our justification is because the function is low high, or because the end behavior is low high. Right? Because low high is always even, or sorry, odd positive, always odd positive. So look at number 6 then. Everybody degree, even or odd? Even, right? They go the same direction. Same direction means even. Does it end high or low? So is it positive or negative? Negative. And then your justification, actually, your justification can literally just be low, low, okay? This has an end behavior of low, low, and low, low always means even negative. Last one, degree, even or odd? Odd, they're going opposite directions. Odd for opposite. Coefficient, positive or negative? Negative, the end's going down. Yep, your justification is high, low. So does everybody see the connection? You can go either way. You can go from the graph and describe the equation, or you go from the equation and describe the graph. Now, the last thing we're going to do here, this is very open-ended. It says write a polynomial function with the end behavior on the left goes to negative infinity. What do we call that? If we're going on the left to negative infinity, is that high or low? Low, right? Negative infinity, low. On the right goes to negative infinity. Is that high or low? Look at it again. On the left, on the right goes to negative infinity. Is that high or low? It's going down still, right? So it's just low, low. It says write an equation that's low, low. You can write an infinite number of equations. You can be super simple. Low, low, y equals negative x squared. Right? Negative x squared, that's even and negative. That would be low, low. That would be the simplest answer. But it's not the only one. You can get as fancy as you want. Y is equal to negative 5 x to the 6th plus 7 x to the 5th minus 10. Does everybody understand that as long as this is my highest degree, that's the important one. I can put whatever I want after it, as long as I don't put a higher exponent. I can put an x to the 5th, x to the 4th, x to the 3rd, x squared, x. None of it's going to matter as long as my highest exponent is even and its leading coefficient is negative. Does anyone have any questions with that? Yes. Whatever you want. You can put whatever number you want on there. You can put negative 1,000,000. It actually doesn't matter. The end behavior only depends on that highest degree. So I just came up with it. Make up whatever you want. So the next one, left goes to negative infinity. Are we starting low or high? right? Negative infinity is low. So we're starting low. Right goes to positive infinity. Are we ending high or low? Ending high. Let's actually write it out specifically here. If it's low, high, what is my coefficient? Even or odd? Odd, because they're opposite. And is it going to be positive or negative since I'm ending high? Positive. So as long as the function you come up with is positive, it's going to work. Odd, positive. So I'll take a volunteer. Somebody give me an equation that would be odd, positive. Go ahead. 3x, take careful, to the third would work. So everybody's clear. And again, this is what we have to practice. If we say 3x squared, yes, this 3 is odd, but that's not what I'm looking for. I'm looking at the exponent. And so I'm really glad that we said that right there, because that's where it's going to be confusing. Which one is the odd one? The exponent. The exponent is the odd one. So that one is odd and positive. Somebody else want to give me an example? One more, maybe? Anyone? Any volunteers here? Say that one more time. Y equals just x cubed. Does that make sense to everybody? What if I subtract an x squared from that? Does that mess anything up? Think about that for a second. Room 611, Mr. Kuhn speaking. Yeah. Okay, I'll let her know. Thanks. Bye. So you're heading out. Just checking at the office. Sounds like an appointment. So the homework's 1 through 25 all. Okay. There's a couple at the end. If you have questions, ask them tomorrow. Okay. So what do you guys think? Does that minus x squared change my end behavior? Why not? It's not the leading coefficient. It's not the highest degree. Yeah. Does that make sense to everybody? So you can put whatever you want on there. What if though, what if I add x to the fourth? Is that still okay? It changes. The x to the fourth takes over, right? The x to the fourth is now my biggest one. So that's no good. I can't do that. But that would be okay, right? Adding an x doesn't change it. So don't get carried away and put an x to the fifth on the end or an x to the sixth if that messes it up. All right, last one, or almost last one here. Sketch a graph of the polynomial function with a leading coefficient and an odd degree. Negative leading coefficient, odd degree. What's my end behavior? I heard a couple of you, but what about the rest of you? What's the end behavior? Turn to the person next to you, tell them. Tell the person next to you, what's the end behavior? All right, so now everybody, what's the end behavior? That was better. High, low is correct. So make yourself a little graph. High, low. Your graph can do whatever it wants to in the middle, as long as it starts high, ends low. So I can literally just make this a straight line, or I can make it do something fun in the middle like this. It doesn't matter. These are all going to have negative leading coefficients and odd degrees, as long as they start high and low. So the number 11, determine the degree of a polynomial in factored form. Demonstrate you're correct by writing the polynomial in standard form. Okay, this one's weird. Real fast, everyone, if you get something like this, it's not in what we've been looking at so far. It's not the same form. It's been factored. So if I want to know what the leading coefficient is and what the degree is overall, I need to multiply it out. Okay, so again, follow along here. Let's try it. If I multiply this out, x times x squared is x cubed. X times negative 3x is negative 3x squared. X times negative 1 is negative 1x. So just multiplying out those, multiplying these out, 2 times x squared, 2x squared, 2 times negative 3, negative 6x. 2 times negative 1 is negative 2. I should not have put that up on top. Let's put it with the other ones. Negative 2. Combine it all. X cubed minus, nope, minus 1, right? Negative 3 plus 2 would be minus 1 x squared minus 7x minus 2. Now, that didn't take too long, but it was several steps. Do I need all of that? Or what is the only piece of that that I need? The x cubed part, right? Anybody have an idea of how I could find that without multiplying it all the way out? Yeah. So it's the two factors. Which piece do I take from each factor? See if we can come up with a rule real fast here, because it'll save us a ton of time in the future. So find the ones with the highest degree and multiply those. Does that make sense? So we took the x right here and the x squared. Those are the two highest degrees. Those are what multiplied together to give me the highest degree overall. You do not have to multiply it all the way together if you take the highest degree of each factor and multiply those. So x times x squared, that's where the x to the third came from. So what's the end behavior of this going to be? So it's like a y equals x cubed graph. So what's the end behavior going to be though? Low, high for an odd positive. And then the last question here is just something kind of out of left field, completely different than everything else we've done, just logic. Yes.
Wouldn't the leading coefficient be negative something?
No, because that doesn't have the highest exponent. I'm glad you asked that. Does everybody understand that the leading coefficient is not the biggest number overall? It's just the one attached to the highest degree. Does that make sense? Because that's something that people often make mistakes with. This could be negative 100. Negative 100x is still going to be smaller than x cubed when I put a big enough value of x in. Does that make sense? The whole point of what we're doing right now, you guys, is thinking about what happens when I put big x's in or really small x's, negatives. Let's say this negative 7 is negative 100 instead. That negative 100 doesn't even matter if I put 1,000,000 into this x cubed. Does that make sense? It's going to take over. It doesn't matter what the rest of the function is. The highest degree is always going to take over on the ends of my graph. So low, high for number 11, and then number 12. How can you shift the following function up 2 units? Anybody remember? What should I do if I want my whole graph to move up? How do I shift graphs up and down? A little louder. The k value, which was just something on the end, added or subtracted, right? So if I want to move this function up 2, what should I add on to the end? A plus 2. Does that make sense? So if I just put a plus 2 here, that's going to move my whole function up 2. The reason I point this out is they're going to ask you later on, can we move this function up far enough so it won't have any x-intercepts? Another way of saying that is can I move this entire function up above the x-axis? Could I do that? Right, if I move this point, if that point is up above the x-axis, it won't have any x-intercepts anymore. That is all the information you guys need to do today's homework. So let's go ahead and stop the recording here. The homework is everything, 1 through 25. 1 through 25 all. You should be able to knock out most of it in the next 15 minutes of class. It should be super fast.